Voyager 1 was expected to find an almost silent frontier beyond the solar system. Instead, it encountered something scientists never anticipated: a faint, persistent signal hidden within the thin plasma of interstellar space. It was not a radio transmission or an artificial message. It was a subtle vibration traveling through charged particles far beyond the Sun's protective influence. That quiet discovery challenged decades of assumptions about what exists between the stars. Beyond the orbit of every planet, past the Kuiper belt and the invisible boundary where the solar wind loses its dominance, Voyager 1 entered a region no spacecraft had ever explored directly. For years, astronomers imagined this vast expanse as a nearly featureless environment filled with sparse particles and weak magnetic fields. It was expected to be calm, almost motionless. But the data returning from Voyager painted a very different picture. Instead of uniform emptiness, the spacecraft detected changing plasma conditions and a continuous background vibration that remained remarkably steady as it traveled farther into interstellar space. The discovery hinted that the region surrounding our solar system is far more active than anyone had believed. What makes this remarkable is not only what Voyager found, but where it found it. This aging spacecraft is the only human-made object operating beyond the Heliopause, the outer boundary where the influence of the Sun gives way to the wider galaxy. Every measurement it transmits comes from a place humanity has never directly explored before. Those tiny streams of data represent our only first-hand observations of the environment surrounding the solar system. They provide clues about the invisible forces pressing against the giant protective bubble known as the Heliosphere, a shield created by the solar wind that helps reduce the amount of harmful cosmic radiation reaching the planets. Yet there is another side to this story. Voyager 1 is running out of time. Launched in 1977, the spacecraft has been traveling for nearly half a century. Its power source weakens a little more each year, forcing mission engineers to gradually switch off scientific instruments to conserve electricity. Every shutdown reduces the amount of information the spacecraft can collect. Eventually, the final instrument will fall silent, ending humanity's only direct observations from interstellar space. Long before Voyager crossed that boundary, scientists relied mostly on computer models and distant observations to understand the space between stars. Occasionally, powerful eruptions from the Sun would send shock waves racing across the solar system. When those waves eventually reached Voyager, they briefly illuminated the surrounding plasma, allowing researchers to estimate its density for a short period. Those moments were valuable, but temporary. Everything changed when Voyager began detecting a continuous plasma vibration rather than brief bursts created by solar activity. The signal remained present year after year, allowing scientists to monitor the density of interstellar plasma continuously instead of only during rare events. For the first time, researchers could observe this distant environment from within rather than trying to reconstruct it from millions or billions of kilometers away. It was like replacing blurry satellite images with measurements taken directly on location. The results were surprising. Instead of a smooth, motionless medium, interstellar space appeared to contain subtle variations in density spread across enormous distances. Invisible waves moved through clouds of charged particles while magnetic fields shifted in complex patterns. Although nothing like weather on Earth, these gradual changes suggested that the space between stars behaves as a dynamic environment rather than an empty void. That realization carries enormous importance because interstellar space is not isolated from us. It constantly presses against the heliosphere, the enormous magnetic bubble surrounding the Sun and every planet orbiting it. If conditions outside that bubble are more active than expected, then the structure of the heliosphere, and the way it shields the solar system from high-energy cosmic radiation, may be more complicated than previous models suggested. The boundary separating these two regions is called the Heliopause. Voyager 1 became the first human-made object ever to cross it, marking one of the greatest milestones in the history of space exploration. But to understand why that crossing matters so much, it helps to revisit one unforgettable moment from Voyager's journey. By early 1990, the spacecraft had already completed its primary mission. It had flown past Jupiter and Saturn, returning spectacular images and revolutionary scientific discoveries. Before permanently shutting down its cameras to conserve power, mission controllers gave Voyager one final instruction: turn around. From billions of miles away, the spacecraft pointed its camera back toward the inner solar system and captured what would become one of the most iconic photographs ever taken. Earth appeared as an almost invisible point of light suspended within a thin ray of sunlight. Every civilization, every achievement, every conflict, every generation in human history existed on that tiny pixel. Soon afterward, Voyager's cameras were switched off forever. To many people, that seemed like the end of its story. In reality, it was only the beginning. Without cameras, Voyager continued its journey into deeper space, carrying only its scientific instruments and an increasingly faint radio signal that required nearly a full day to reach Earth. For years, those instruments recorded subtle but important changes. The outward flow of charged particles from the Sun gradually weakened, while energetic cosmic rays arriving from outside the solar system steadily increased. The transition suggested that Voyager was approaching one of the most significant boundaries in space. Then, in August 2012, the spacecraft officially entered interstellar space. Rather than finding a simple dividing line between the solar system and the galaxy, Voyager revealed a far more complicated frontier. Scientists expected dramatic changes in nearly every measurement. Some did occur, including shifts in particle populations and plasma density. But other observations, especially the magnetic field, changed more gradually than many theories predicted. Instead of a sharp edge, the heliopause appeared to behave more like a broad, complex transition zone where the influence of the Sun and the surrounding galaxy interact in ways researchers are still trying to understand. And hidden within that mysterious environment was the quiet plasma vibration that continues to puzzle scientists today.